I'm finally in 2020. I've been writing 2019 a lot. So which one did you have, Chris? You had the blue one. Okay. So the 2x plus 6, everything divided by 3, in absolute value minus 1 greater than 3. Okay, so in this particular situation, we have to clean it up. Cleaning it up, or simplifying, in other words, I'm trying to be funny, we have to add 1 to both sides. And only then we identify the type of inequality. Yes. So now this is the situation in which we have to separate, because I don't want you to memorize anything, but remember how we read this. I mean, we have to read it. So find numbers whose distance from 0 is more than 4. More than 4 means to the sides, meaning this number, 2x plus 6 over 3, must be greater than 4, or 2x plus 6 divided by 3 has to be less than negative 4. I can tell you numerous stories from, yes, please. I just got it from the testing center. Yes. If you want to wait after class, I'll grade it and give it to you. I need a few minutes. But I was waiting in line for them to do the test. Okay, so I have numerous stories from my students who, at the beginning, like probably some of you, did not get into a routine, did not understand how to study. So they started very low. Their grade was very low. And all of a sudden, it shuts up. Or shut up, or it went like a bullet, right? And I said, what did you do? I finally understood what you want me to do. I'm watching your videos. I'm watching this several times, and now I know what to do. And I'm following step by step, and things started clicking. I have numerous stories. I even asked them if I could tape them, so I can put up or present the video to you, so you hear directly from them. Not hearsay from me, right? So eventually I'll find some who would come back and I will tape them explaining how they study for the class. Okay? Everyone can do this, I guarantee you. But you just have to put it in your calendar, on your schedule every day. And you will get there. And I will help you. Okay, so obviously I have to get rid of 3 here. So I will multiply by 3. You don't have to solve both at the same time. 2x plus 6 greater than 12. You are subtracting 6 to get this. And then you are dividing by 2 to get this. So this is the result for the very first one. For the second one, everything is the same. It's still 2x plus 6, but less than negative 12. And when you move 6 and divide by 2. This type has to have the union in between. So first one, it's going to be the negative infinity to negative 9, and the other one, 3 to infinity. There are only 2 types of absolute value inequalities. Only 2. I would say, yeah, it's difficult because there are 15. It's difficult to even put them in the category, right? But there are only 2. There are only 2. Right? Either the absolute value is greater than a number, or the absolute value is less than a number. You can't have anything else. Good. Anything else? Is there anything else? I have to move on. I have written the solutions. Of course, I always do before I start grading. I am going to scan these, but tonight after my last class, and I will post them tomorrow. I will post the blank test as well. Actually, I have a few left over. They made 2 more copies for me if anyone is interested, so you don't have to print it at home. Blue, white,
So when it comes to the final, is it going to be like these questions as
Correct.
far as
Similar questions, not exactly the same.
oh the like
Is that clear? The blue. Which one? I don't want to shred them. I'd rather give them to you, right? So instead of you printing them out.
The next time we get it, can you like write on your practice, because the guy in the tutor lab didn't want to help me because he thought this was a grade because it said chapter test or whatever.
Finally, somebody who's asking about that. Nobody in the past has ever asked. I mean,
Yeah,
the person in the lab.
yeah.
Give them my number.
Okay.
Ask them to call me. Okay. First of all, I need to get to know them too. Okay. Any questions? Is there anything else?
Are you just talking about what she did to review? You wouldn't help you
Yeah.
Yeah. Just say, well, call me on your cell phone and give them your cell phone, and I'll talk to them. What can I do? I don't have a stamp to put a stamp practice or something. Okay. Anything else? Yes. Yes, the piecewise defined function. Vinny, what did you want to say?
Yeah, same thing on the piecewise.
Yes.
When you give the domain and the range, you don't have to split them separately.
Why would you do that? It's
'Cause it's two
extra.
separate
It's
functions.
extra work.
Okay,
I am splitting the function already.
right.
Why would I do it separately? So for this one, Bernie, did you have the blue form or the white form? Okay, perfect. So we have f of x equals 2x minus 4 for x less than 2, and negative 3x for x greater than or equal to 2. Okay, so first of all, the domain, negative infinity to 2 and 2 to infinity. Remember, you cannot write negative infinity to 2 union 2 to infinity. Many of you did that. It's everything. If I have everything to the left of 2, I have 2, and I have everything to the right of 2, obviously, it's all real numbers. This is the way we write it, like this, domain. You don't have to write it like that. So now knowing that, I create a table that has to have 0 and 2 mandatory in the table. These are the symbols. Here is I'm going to present the values of y. I see that to the left of 2, I'm already splitting it. It's 2x minus 4. That's why I put this here. It's already split. And then on this side, I put negative 3x. One student reversed these two, and everything was unacceptable. I couldn't give any credit. So that's why I write it here. So to the left-hand side of 2 is 2x minus 4. To the right-hand side of 2 is negative 3x. Now, what you did over there, if I may say, in negative 3x, you plugged in 0. You plugged in negative 1 in negative 3x. You can't do that. That's why I crossed it out. You cannot plug in 0 in negative 3x. Negative 3x is only here. You can only plug in numbers from 2 to infinity. Is that clear? Yes, everyone? Okay, so when I plug in 0, I get negative 4. When I plug in 2, I get 0. When I plug in 2, I get negative 6. When I plug in 3, I get negative 9. This is it. You understand why in negative 3x you cannot plug in 0? Is that clear? Vinny?
Yes.
Okay. Is it clear why you cannot plug in 3 in 2x minus 4? Okay, perfect. It's not a mistake. I didn't deduct points. Everything you did was perfect. But I crossed that out because I don't want to see that.
Right.
You can't plug in negative 3x, negative 5. Like you cannot plug in 10 in 2x minus 4. You cannot, in other words, what I'm saying is you cannot plug in the same x value in both functions. It's not possible. It's not a function anymore if you do that. And as I was afraid of, many of you graphed this. And I circled it, and I said, this is not a function. It cannot be accepted. By the vertical line test, it's not a function. So please, if I did that, so please make a note. Okay, so now we're ready to graph. Also, Kosha asked last time if we can extend the test. Yes, the answer is yes. Whatever works for you, I'm fine. But please don't tell me the day of the test. When everybody is ready and so on and so forth. We discuss, we set up the date. If you think, like 2 or 3 days prior to that, if you think that you need more time for the test, email me and I will extend the test for everyone. Is that clear? Okay. Perfect. So I want to work with you. Is that understood? I'm doing anything in my power to help you.
So you're talking about if they were here past 3:15? Is that what
We
you're?
weren't ready for the test.
Okay. I thought you meant like more time to take the test.
That's fine. I always give
No,
my students
never
more
mind.
time.
was
I
just
always do
confused.
that. So 0, -4, that's okay. And 2, 0. So this is the graph on the left-hand side, and it's done. You cannot plug in anything else. It's finished. Now 2, -6 is this point, and 3, -9 is this point. So here's the graph. Two completely distinct pieces that can never overlap. So this piece cannot be extended to the left, this piece cannot be extended to the right. And this is the entire function. Like with everything, we need to see things over and over. It's not, bless you, it's not going to happen just seeing it once. For some, it's possible, but not everyone. That's why I post those videos all the time. And you will do better. Trust me. Okay, anything else? Anything else? Okay, so let's continue. We have to continue with and try to finish chapter 2. We have only 2 weeks left before the spring break. And we have 2 more tests and a ton of material. Okay, so hold on to your seats. Okay, so we are going back to where we left off, meaning we finished 2.4 and we did not start 2.5. Okay. In 2.5, called transformations, before I even explain what this means, we have to talk about simple functions. Every category of functions has one that is the simplest possible function. So for example, linear. So I'm not talking about transformations just yet. This is the preliminary. I need this discussion before we look at transformations. So the simplest possible linear function, what do you think it would be? Then we're going to move to quadratic. Exactly. This is the simplest possible function. There is nothing simpler than this linear function. There are other linear functions out there, of course, but this is the simplest one. We have to remember how to graph this. So here's the graph of y equals x. Or f of x equals x. Is this function symmetric? Yes or no? What type? Perfect. Thank you. This is an odd function because it's symmetric with respect to the origin. Quadratic. Can anyone give us the simplest possible quadratic function? Excellent. Here's the graph of x squared. Odd, even, or none of the above? Excellent. Indeed. Next function, square root. Can anyone give us the simplest square root function that you can think of? That's it. Here's the graph of the square root of x. All these were determined at some point in time or graphed at some point in time. You've seen these before. I'll be more than happy to go into more details, and we will. Here's the graph of the square root of x. This is not a straight line. Do not graph it as a straight line. Okay, so my question here is it odd, even, or none of the above? Not symmetric. Awesome. Very good. Next one. Cubic function. Can anyone give us the easiest, simplest possible cubic function? We used it before, and you'll tell me, you'll see it in a moment. You've seen it before. Is this odd, even, or none of the above? Thank you. It is an odd function, symmetric with respect to the origin. Perfect. Next one. Absolute value. Can anyone give us the simplest possible absolute value function? Of course, thank you. Here it is. It's like a V function. It's like a V. So is it odd, even, or none of the above? It is even. In your book, somewhere, I know I've seen it, yes, here it is. They present this list. They have 7 functions here. We looked at the square root. This is on page 283. We looked at the square root. We looked at the absolute value. We looked at the linear function. This I really don't need, to tell the truth. We looked at the square, the quadratic x squared. And we looked at x cubed. So let's also look at the cube root of x. And that's good enough. That's all we need, really, for now. So we had square root, so let's look at cube root. Can anyone give us the simplest possible cube root? Of course. It is the cube root of x. And it's kind of similar to the square root, but as we know, you can take the cube root from positive as well as negative values. Odd, even, or none of the above? Odd. Okay. Now I'm sure you're asking yourselves, or you want to ask me, fine, this is beautiful, but why? Why do I need to know these shapes? Linear, quadratic, square root, cubic function, absolute value, and the cube root. Why do I need to do that? So here's a reason. And I like this graph in your book. So let's take a look. So let's suppose you are conducting a study. You're interested to know if there is a relationship, or you can model the height of boys from whatever, 0 months of age till 60 months of age. And you measure many of them, and you come up with an average for each month, for 0 month, for 1, for 10, for 20, whatever, and you plot these points. You plot a point here, one 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 here. And then you want to say, okay, let me see which function I could fit in there. And you think of a linear. No. You think of the quadratic function. No. Look at this one. Is this one going to work? Of course not. Is the absolute value? No. Is the cube root? No. This is the perfect model, the square root. But it's not exactly the square root of x. It has transformations on it. But it's the shape of the square root. That's why we study transformations. To be able to understand the function better, be able to graph it with our minds, eyes, literally, we'll see in a moment, and not rely on the calculator unless we need to. Okay, so now we can start transformations, finally, because all these transformations are applied to these functions. If I don't know how to graph these 7 functions, 6, 7 functions, then I don't know how to apply transformations. Transformations make no sense if I don't know these shapes. That's why we reviewed them first. Okay, so there are 3 types of transformations. Shifts, and they are of 2 types. Reflections, and they're also of 2 types. And stretching or shrinking, also of 2 types. Shifts, reflections, or stretching and shrinking. Let's start with shifts. Horizontal, vertical. So I'm going to start with that. I'm going to give examples on both, and then we'll come back to reflections and then stretching and shrinking. Let's suppose I want to discuss or look at or graph the following function. And then later on, not related, not necessarily related, which base function or simple function from the list that we just looked at, that we just named, I used to create f and g? Common sense, right? You read the function, and once you say the absolute value, it has to be the absolute value, right? Perfect. So I use this function, which I know how to graph. I just graphed it. Symmetric. It bisects the first quadrant and bisects the second quadrant. So that's the absolute value of x. Now the question is, how do I graph this? Where is the x-intercept for this graph? At 0. Excellent. Where do you think, just think, where do you think the x-intercept for this graph will be? The x-intercept means what? How do I determine the x-intercept for any function? How do I determine the x-intercept for any function?
Y equals 0.
Exactly. So where is this function 0?
3.
Exactly. Which means that this is a shift of the original graph of 3 units to the right. This is x minus 3, and it is 0 at 3. I know kind of you're expecting to shift this graph to the left, but no, it's to the right. Because you're looking for where it has the x-intercept. Okay, how will I graph the other one, x plus 4? Where will that have the x-intercept? Correct. Very good. So this is it. So this is the absolute value of x plus 4. So the first graph, it's a right shift of 3. Right shift. I didn't leave enough room between those two. I'm so sorry. Right shift of 3 units. This one is a left shift of 4. What is extremely important to understand here is this. When you compare these two functions, you see that this is x, nothing added and nothing subtracted, right? But this is x minus 3. Same thing here, x and x plus 4. So what am I changing? Obviously the answer is I'm changing x. So x was changed into x minus 3, or x was changed into x plus 4. Every time I change x, I have to do this. So it's a horizontal shift, of course, a horizontal shift, either to the right, 3, or to the left, 4. We are changing x. A horizontal shift changes x. Okay, so that was our horizontal shift. Let's take a look at the following scenario. Now I want to graph x squared minus 4 and later on x squared plus 5. Which base function or simple function I used this time? Right? I used y equals x squared. We agree? Good. I know how to graph y equals x squared. Here it is. And now let's identify what we change. Do we change x? No, I'm not changing x. It's the same x squared in both. But if I'm not changing x, it means that I cannot change both at the same time. If I'm changing x, I'm not changing y, and vice versa. So what am I changing then if I'm not changing x? I'm changing y. So changing y, and how? What does this operation do to this graph? Where? Which direction? Say it again. Yes, awesome. Where? Careful. So when x is 0, y is 0 here. But when x is 0, how much is y now? Yes, not up, but down. So here's the graph. So this is x squared minus 4. Is that okay? So this was x squared and x squared minus 4. Now, what type of shift is this? Yes, it's a vertical shift. Down 4. How will you graph x squared plus 5 then?
Vertical shift, up 5.
Very good. Here it is. This is x squared plus 5. The shape doesn't change. My graph is not perfect. I'm so sorry. The shape is the same. It's shifted up 5 units. So that is the vertical shift. Now I'm going to create a function, and you will tell me what I used. Which base function or simple function did I use now? Say it again. Very good. Awesome. The square root of x. Now, in order of operations, I see here 2 transformations, not just one. What will it be? What will the first transformation be in order of operations? When I say order of operations, I mean If I ask you to evaluate this function when x is 5, which operation will you perform first?
5 minus 4.
5 minus 4. That's your starting point. Then you apply the square root to that number, and what do you do next at the end? Add 3 in the order of operations. So then what is the first transformation on the square root of x in order of operations?
Square root of x minus 4.
Square root of x minus 4. What does this do? What does this function do to this function? What is the transformation?
Which is right.
Right 4. Excellent. Now, finally, number 2, transformation number 2 is on function number 1. This is gone. So now the last one, which is the square root of x minus 4 plus 3, is a transformation on this one. What are we changing now? Here we had x and then x minus 4. Obviously, it has a left-right, right? It's a horizontal shift. I'm changing from x to x minus 4. But now x minus 4 does not change. I'm only adding 3 to this quantity. When I add 3 to a quantity which is not x, it's the previous y value, what transformation is this?
Is it up there?
Up 3. Up 3. So then I graph the base function. I call it a base or the simple function. Here's the simple function, the square root of x. Then I will have to move this graph 4 units to the right, as you said. Perfect. And then you told me to shift this graph up 3. So this is the square root of x minus 4 plus 3. Questions on this? Questions? Yes, please. Natasha, go ahead.
But for the x square root minus 4 plus 3, it goes over 4 and up.
Yes. Yes. Because we first change x into x minus 4, which shifts the graph to the right 4. And then this plus 3 shifts this graph up 3. Better? Perfect. Good. So we're going to talk about reflections now. Let's suppose I want, I create this function. And then later on we'll talk about g of x, like this. Which base function I use this time? Good. So I use the square root of x. Now let's compare. I want to start with g for a second. Am I changing x or I'm changing y? Yes, because the change touches x. Right here. X and negative sign are in immediate vicinity, right? So x, initial x, was changed into negative x. So here's what happens. When I change x into negative x, or x into negative x, what am I doing to the graph? With respect to what? Excellent. So let's graph the square root of x. So here's the base function, the square root of x. And then you told me to reflect with respect to the y-axis. And this is the square root of negative x. And that's g of x. Now let's compare again. This time I'm comparing these two. Does the change touch x? Or do I have the same x? Same x, so it doesn't touch x. So then if it doesn't touch x, this is the y value. It means that it touches y. So here I had a positive y, But here I have a negative y. What happens when I have a positive y and I change into negative? Or I have a negative y and I change it into positive? What am I doing now? Reflecting with respect to the x-axis. So this graph is the original one, not the second one, right? The original graph, the base function, gets reflected, and this is negative the square of x. So these are the two possible reflections. Reflection with respect to the y-axis and with respect to the x-axis. WRT, the y-axis, WRT, the x-axis. And let me give you a combo now. The first one was with respect to the y-axis. It doesn't matter. The order is not important, what you put them in. With respect to the y-axis and with respect to the x-axis. Okay, so let's take a look. F of x equals negative the absolute value of x plus 2 minus 3. I'm giving another example of a combination. We have 3 transformations in this one. In order of operations. First transformation in order of operations. First of all, please tell me which function I used this time. I used again the absolute value of x. The first transformation, second, and third. Only the first transformation is on the base function. The second one is on the first. The third one is on the second. In order of operations, which one is the first? Say it again. X plus 2. Very good. The absolute value of x plus 2. What does this do to this graph? Left 2. Excellent. The next in line would be what? Exactly. I have to multiply by negative 1. Excellent. So negative the absolute value of x plus 2. Am I changing x? No, I'm not changing x. Because the negative sign is completely outside of x. It touches y. So this was the y value. Now this is negative y. What type of reflection will that be? With respect to the x-axis. Reflect with respect to the x-axis. And now the final is last. Of course, there is nothing else. I have to copy it. What will this do to the previous function? This, what does it do to this function? We already reflected. We cannot flip again. Down 3. Very good. Down 3 of number 2. The function from number 2 goes down 3. The function from number 2 is the same with number 2, but down 3. Now, this multiplied by negative 1 will reflect. This, subtracting 3, will be down 3. Ready to graph? So let's graph all of them. We graph the absolute value first. That's the base function.
You mentioned to the test or whatever homework is like put the.
You have to put the yes.
Yeah.
Yes, it will get you started. That's because if you don't have the original
But
shape,
like, you will take points off if we don't put the actual original thing on the origin. Right?
I will not. But how will you create the next and the next and the next if you don't have the original one? That's my question.
Well, I mean, if you understand it, you should.
That's fine.
Okay.
If you can do it without graphing the original function, that's fine. Okay, so then you told me to shift it to the left 2. You will not be able to keep it in shape. That's my concern. So this is the absolute value of x plus 2. Then you told me to reflect this graph. Fine. I am going to reflect this graph with respect to the x-axis. So this is negative the absolute value of x plus 2. And then you told me to shift this up 3. Down 3, sorry. 1, 2, 3, right here. So this is the graph of negative, the absolute value of x plus 2 minus 3. I'll do this just for you to make sure that you remember that this is the final graph. Questions? Okay, so stretching and shrinking now, the last two. One of them is quite straightforward, but the other one is the opposite of what you would expect. So let's take a look. So let's say this time I want to graph 2x squared and g of x as 1/2 x squared. Any questions on the previous problem? I should have asked them, giving you a second. Any questions on the previous question? Okay. Good. Which function did I use now? Of course, x squared. I'm going to graph it here. So here is x squared. And what do you think that number, that first number is greater than 1, right? Like it's 2. What do you think multiplication by 2 will do to the graph? First of all, are we changing x? Are we changing x? Correct. We're not changing x. This is 1x squared, but this is 2x squared. So obviously, the change happens outside of x, because this is the same. Perfect. So what do you think will that do? From x squared, exactly, awesome, exactly. It's a vertical stretch. So all these are wide values, right? Multiply all of them by 2. So from x squared to, or twice x squared. What do you think 1/2 in front will do to x squared?
Lower.
Right. So the first one is called vertical stretching, the other one is called vertical shrinking. Perfect. So 2x squared is a vertical stretching by a factor of 2, of course. And the other one, 1/2 x squared, or 1/3 x squared, or 1/5 x squared, any number that is less than 1 is a vertical shrinking. Of course, by a factor of 1/2. Okay, let's look at a combo. And then the last one. We can choose a problem from your book, or I can make one up. Let me make one up.
Did you want to do double answers or did you do it on the graph?
Of course I want to graph them. Thank you very much. I showed, but I didn't graph them. Thank you very much. So this is twice x squared. Great. Thank you. Sorry about that. Thank you. Perfect. So let's look at a combo and then the last one of the transformations. So let's say we want f of x equals -2, the absolute value of x plus 1 minus 3. Let's make it plus 3 this time. Okay. What function did I use? Good. So here it is. So here's the graph of the absolute value of x. First transformation? Exactly. Left one. Great job. So number 1 is x plus 1, left 1. Number 2 is a transformation on the absolute value of x plus 1. yes, if I ask you to evaluate this function for 2, you would say 2 plus 1, the absolute value is 3, and then you'll multiply by -2. You will not multiply 3 by -2 and by 2 and then by -1. But this time we have to separate because there are 2 operations in there, 2 transformations. So first we're going to say 2x plus 1, and then -2x plus 1, and finally the -2x plus 1 plus 3. We don't do that. We don't multiply by -1 and then by 2, or by 2 and then by -1. We multiply by -2. But there are 2 different transformations, and we have to present it like that. So the first one is left 1. What will the second one do to the first one? Not to this. Stretch it by a factor of 2. Very good. Vertical stretching. I'm going to vertical stretch the blue graph by a factor of 2. Something like this. So this is 2 times x plus 1 in absolute value. Okay, what does this do to that? Reflect, yes, reflect with respect to the x-axis. Here it is. So this is -2, the absolute value of x plus 1. Final graph. So this is reflected. Reflect with respect to the x-axis. And finally, up 3. So up 3 means this. And this is the final graph. So this is -2, the absolute value of x plus 1 plus 3. Questions?